Good morning students. In the previous class we learnt about rational numbers, finding a rational numbers between any two integers, any two whole numbers or any two rational numbers, isn't it? So we have learnt this. So now based on that let us do the exercise sum. Okay. So let me do that, the exercise sum. So exercise 2.2. Represent on the number line. Represent on the number line. 7 by 4. So it is 7 by 4. So let me draw the number line. Here it is positive. So let me add 0, minus 1, minus 2. Then here it is 7 by 4. See the denominator. If you see the denominator, it is 4. That means it divided into 4 equal parts. Okay? Again you do it. 4 equal parts. Like that. So you will have 4 equal parts means 1 by 4, 2 by 4, 3 by 4, 4 by 4 is 1, isn't it? Next, 5 by 4, 6 by 4, 7 by 4, then 8 by 4 which is equal to 2, isn't it? So now you know, what is this? We want 7 by 4, so 7 by 4 is this one. Yes? Understood? Yes. Let me do minus 5 by 6. That means here it is negative. So let me move on to the negative side. Okay. If I move on to the negative side, see the denominator, it is 6. So the first part is I should divide 6. 1, 2, 3, 4. So let me divide. Okay. So this side what you will have? Minus 1 by 6. Minus 2 by 6. Minus 3 by 6. Minus 4 by 6. Minus 5 by 6, minus 6 by 6, minus 6 by 6 is minus 1, isn't it? 6 by 6 is, but I want which one? Minus 5 by 6, so I got it. So you can write minus 7 by 6, minus 8 by 6, minus 9 by 6, like that you can go on writing. Okay, but I want minus 5 by 6, which is already there on the number line. Okay, understood? Yes. Represent minus 2 by 11, minus 5 by 11, minus 11 by 9 by 11 on the number line. So now you should represent this on number line. So how will you represent? See the denominator. When you see the denominator, all are divided by 11. All are having negative. So let me consider on the number line only the negative side. Okay. Because you will have both positive and negative on the number line. So let me have 0, 1, 2. So this side you will have to divide by, yes, 11 by 11 is 1. So I should divide this into 11 equal parts. by 11, minus 9 by 11, minus 10 by 11, minus 11 by 11, which is equal to minus 1. Okay? Because the denominator contains 11, I have divided into 11 equal parts from 0 to minus 1. So now I got minus 2 by 11, minus 5 by 11, and then minus 9 by 11. All this I got because I divided the number line. On the number line, you see the denominator. Denominator contains 11 divided into 11 equal parts. Then you name it. Okay? Minus 1 by 11, 2 by 11, 3 by 11, 4 by 11, 5 by 11, 6 by 11 along with the negative sign. So you can mark all the rational number which they have asked. You can plot it on the number line. Okay? Okay. Next. Let us move on to the next. Write 5 rational number which are smaller than 2, which are smaller than 2. So you must write the rational numbers which are smaller than 2. How will you write? Just write the number line 0, 1, 2, smaller than this. So you move towards left, so you will have negative also. So smaller than 2 means you can write any number and dividing by 1, it becomes a rational number. Okay. So it is smaller than 2 means, so in between you will have a half, 1 by 4, 3 by 4, you know this one. Isn't it? All are less than 2 only, isn't it? So you can write any one. So 0 is also a rational number. You can write 0, 1 by 4, yes, 1 by 2, 3 by 4. 1 by 1 is also a rational number. Okay, it is in the form of p by q. 1 and a half, 1 by 4. All are smaller than 2. This side you can write minus 1 by 2, minus 1 by 4. That also you can. So you can write any number of rational numbers which is less than 2, because all negatives are less than positive only, isn't it? So you can write any number of rational numbers less than 2. Okay? Understood? So by writing the number line, you can write n number of infinite number of rational numbers less than 2. So whichever is easy, that you can write. Okay? Understood? Yes. Let me move on to the next one. Next is find 10 rational numbers between minus 2 by 5 and up. Find 10 rational numbers between minus 2 by 5 and up. So I should find out between these two. Okay. So how can I find? We have learnt methods, isn't it? By using that, you can find infinite number of rational numbers. So before that, you must see, are they equivalent? No. They are having different denominators. First, you make it as an equivalent rational numbers. Okay? That means the denominator should be same. So what is the LCM of 5 and 2? 5 and 2 are prime numbers, isn't it? So what are called prime numbers? The number which are divisible by 1 and the same number are called prime numbers. So 5 and 2. So what is the LCM of 5 and 2? When prime number is given, you just multiply. So you can write 5 2s are 10. Multiply and write. Now let me multiply both the rational numbers which are given by, yes, if I multiply by 2 only, I will get 10. So minus 4 by 10. 2 2s are 4. Again, if I multiply by 5, 1 5s are 5, 5 2s are 10. See, if I want to write between minus 4 by 10 and 5 by 10, 10 rational numbers I should write. So which are the rational numbers I can write? Minus 3 by 10, minus 2 by 10, minus 1 by 10, 0 by 10, 1 by 10, 2 by 10, 3 by 10, 4 by 10. I can write how much? Only 8. But here he is asking 10. So I can do some other. Again make an equivalent fraction of the given rational numbers. Now you have written minus 4 by 10 and 5 by 10. You can multiply by 2 so that it becomes 20. So multiply by 2. Both numerator as well as the denominator. If you want, you can multiply by 2, you multiply by 5, multiply by 7, multiply by 10, multiply by 100, anything. Okay. So minus 8 by 10, 20, 10 2s are 20, 4 2s are 8, 10 2s are 20. Again 5 2s are 10, by 10 2s are 20. Right in between. How many rational numbers you can write? Minus 8 by 20. See right now, yes, minus 7 by 20, minus 6 by 20, minus 5 by 20. I can write, isn't it? Yes, 4 2s are 8, 5 2s are 10. So, minus 4 by 20, minus 3 by 20, minus 2 by 20, minus 1 by 20, 0 by 20, 1 by 20, 2 by 20, anything. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I can write. So even up to 9 by 20 you can write. In that you can choose any 10 rational numbers and you can write. Understood now? So if I take the LCM of 5 and 2, I got only few, that is 8 only I got. So to get more, that is because he is asking 10. So to get 10 rational numbers, I must change. Again I multiply both numerator as well as the denominator by 2. So that again the denominator becomes same, 20. Okay, so minus 8 by 20 and 10 by 20. So the denominator is same, so you have got an equivalent fraction, that is rational numbers. So now you can write as much as you want. Here he is asking only 10, so I have written only 10. You can take up to 9 by 20, in that whichever you want you can choose under it. Okay. Let us move on to the next one. Now, again, find 5 rational numbers between 2 by 3 and 4 by 5. See the denominator. Are they same? No. So, I should find out the LCM. So, what about 3 and 5? LCM of 3 and 5. Yes, both are prime numbers. So, just multiply and write 3 into 5 is 15. So, you can have 2 by 3 into, if I multiply by 5 only, I will get 15. Similarly, 4 by 5, if I multiply by 3 only, I will make it 15. So, 2 5s are 10, 3 5s are 15. Okay? 2 5s are 10, 3 5s are 50. 4 3s are 12, 5 3s are 50. See, even though they are like fractions, because they are having 15 as the denominator, if it is 10 by 15 and 12 by 15, you will have only 11 by 15 in between. Whereas here he is asking 5 rational numbers. So, when he asks 5 rational numbers, how can I write? So, again you multiply. You multiply by the same number, both numerator as well as the denominator. So, if I multiply by 2, 20 by 30, 24 by 30. See, if I multiply by 2, what I will get? 20 by 30. 12 2s are 24 by 30. In between, how much I will get? 21, 22, 23. Only 3 rational numbers I will get. So, no need of multiplying by 2 now. Let me multiply, instead of 3, let me multiply by 4 and find out. Okay. So, let me multiply by 4, because 10 4s are 40, 15 4s are, yes, very good, 60. Again, 12 4s are 48, 15 4s are 60. So, what is the rational numbers that exist between 40 and 48? You can write 41 by 60, 42 by 60, 43 by 60, 44 by 60, 45 by 60. I need only 5. So, I have written only 5. So, up to 47 you can write, isn't it? So, like that you should see whether if you get 2 or 3, you multiply by more numbers, both numerator and denominator, so that you get more rational numbers between the given 2 rational numbers. Okay? Then, let us move on to the next one. Right? 5 rational numbers between 2 by 3 and 4 and 5. The second one is minus 3 by 2 and 5 by 3. Same heading, sum is 2. You tell me now, again the denominators are different. So, what is the LCM of 2 and 3? Both are prime numbers, just multiply. 2 3s are 6. So, minus 3 by 2, 5 by 3. So, 2 multiplied by 3 will give you 6. 3 multiplied by 2 will give you 6. Okay. So, when you multiply by 3, the numerator also to be multiplied by 3. So, minus into plus is minus, 3 3s are 9. So, 3 2s are 6, so 5 2s are 10. So, minus 9 by 6, 10 by 6. Now, you want 5 rational numbers. You get 5 rational numbers between these two. Yes? Which are the 5 rational numbers, you tell me? Yes, let me write. Tell me now. Yes. Minus 8 by 6, minus 7 by 6, minus 6 by 6. Yes. Minus 5 by 6, minus 4 by 6. So I got. Isn't it? Finished. Okay. Now, one more is given. Let me do it. 1 by 4 and 1 by 2. So, what is the LCM of 4 and 2? Yes, 4 and 2. 2 2s are 4, 2 1s are 2. Again, 2 1s are 2. So, what is the LCM? 2 into 2. So, I can write the LCM is. So, LCM of 4 and 2 is 4. So, 1 by 4, if I multiply by 1 only, I will get 1 by 4. 2, I should multiply by 2 so that I can multiply the numerator also by 2. So, 2 by 4. So, 1 by 4, 1 2s are 2, 2 by 4. Can I get 5? No. So, if you want, you can multiply both numerator as well as the denominator by the same number. If you multiply 5, 6, 7, 8, 9, whichever is easy, you can multiply. See, always multiplying by 10 will be easy, isn't it? Always multiply by 10 will be very easy. So, what you will get? 1 tens are 10, 4 tens are 40, 2 tens are 20, 4 tens are 40. So, 20 by 40. So, can you write 5 in between them? Yes, you can write very easily. So, you can write 11 by 40, 12 by 40, 13 by 40, 14 by 40, 15 by 40. That's all. Okay, understood? So, if you won't get in between, so for in between, if you won't get 5 rational numbers, multiply both numerator as well as the denominator by the same number to get more number of rational numbers. Okay? Write 5 rational numbers. Next one. Greater than. Now greater than minus 2. So write 5 rational numbers greater than minus 2. See, you will have 0, minus 1, minus 2. Here it is positive. Okay. So greater than minus 2. This side you should consider. So anything you, whatever you want, you write. You can write minus 1.5. Isn't it? Plus 1.5. Half. 1 by 4. 1.5. 2 and half, 3 and half. Any number of rational numbers you can write greater than minus 2. Isn't it? All are greater than minus 2. Understood? Yes. Find rational numbers between 3 by 5 and 3 by 4. Find 10 rational numbers. So you must find 10 rational numbers between 3 by 5 and 3 by 4. So what is the LCM of 5 and 4? So what is the LCM of 5 and 4? Yes, if one is a prime number also you can multiply. You will get same. So 5 into 2 into 2. 20. So the LCM is 20. So multiply 3 by 5. Yeah, when you multiply by 4 only, you will get 20. 3 4s are 12, 5 4s are 20. Then 3 by 4 into 5. Because 4 5s are 20. Can I write 10 in between them? No, 13 and 14 are there. 13 by 20, 14 by 20. So I got only 2. What I should do? Yes, I should multiply by same number to get. So let me multiply by 5 both. Let me find out whether I will get. 12 5s are? Yes, 60. 20 5s are 100. Again, 15 5s are 75 by 100. Can I get 10 now? Yes, definitely. 60 to 75 means there are 14, isn't it? So I can write 61 by 100. So the 10 rational numbers. Are 61 by 100. Yes, 62 by 100. 63 by 100. 64 by 100. 65 by 100. Then write. You can write 66 by 100. 67 by 100. 68 by 100. So how much I got? 2, 4, 5, 6, 7, 8. 69 by 100 and 70 by 100. So I got 10. I can write up to 74. But I got 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay? Now you understood? Yes. So now I completed the rational number chapter. Let me teach you a new lesson in the next class. Thank you, students.